Before we start, I would like us to just play a guessing game. Who can guess how long passwords have been around for, or like when they were invented? Just randomly, just throw a random number. Yeah? Sorry? Yeah, 90s. Yeah, 1961 precisely. So passwords have been around for like 70 years, and they were introduced by MIT professors who wanted to like create a mechanism for individual access to a console, and they've been around for 70 years. And in that 70 years, we've witnessed iPhone, IBM Watson, self-driving cars, quantum cryptography, Bitcoin, blockchain, and a lot of technological advancements. And it's still worrisome that we've, up till this time, relied on this piece of technology for this concept that is over 70 years old for identification. But the good news is that we don't have to anymore, because passkeys are now available. And so that's what we'll be talking about in this talk. So if you've heard of passkeys here, just show of hands. Okay, quite a few number. Okay. So if you've heard of passkeys in passing, you're in the right place. And if you haven't heard of them too and you want to learn about them, you're in the right place too, because today we'll be covering what they are, a 2-minute sermon on why passwords are the cause of all our problems, why they matter, why you should care about them, and how you can start to integrate them into your applications and websites. And we'll look at a bit of considerations and gotchas to be aware of why you're implementing them. So, a bit of introduction. I'd like to point out that she actually murdered my surname. It's Ikechukwu. It's a Nigerian surname. I'm not a passkey expert, and unfortunately, I wasn't part of the team that, built it. Their loss. But what I am here is someone who has done a lot of research around passkey and championed for my company to add it into authentication flow. And that's why I'm here to talk about it, because as a user, as a consumer, passwords frustrate me, and I would like to see them gone. So let's get into what passkeys are and the why they are so important and why they need to exist. First of all, the average human here, me, I have over 50 accounts on like consumer applications. And for each of these accounts, security best practice expects me to come up with something complicated that, one, would be easy for me to remember, but then at the same time, difficult for computers to guess. And that's just bizarre. Now, for each account, I have to do that. And in doing this, some users have become very innovative and have manufactured this password book so that they can log all their passwords. Because, and before you ask if this is a real product, it is actually, with a lot of reviews on Amazon. And people are using them. It has like over 130,000 buys or something. And people are using them. And you can't blame them, because that's how frustrating passwords are. Keeping track of them is just stressful. And that's one of the major flaws of password-based authentication, is that it puts the burden of authentication on users, which is not supposed to be so. And that's one problem that passkeys solves. Passwords also encourage unsafe behaviors, in the sense that when we finally come up with this standard, complicated, complex password that, meets the acceptance level of a lot of applications, we tend to reuse those passwords across all or most applications that we have. And so what happens is that if the password for one account is leaked, then it can be used in a credential stuffing attack to get access to other accounts that a user may have, because statistically they are bound to use the same password across most of their accounts. And to put that into context, some data, a publication from Okta states that 24.3% of all login attempts on their Okta Customer Identity Cloud are considered credential stuffing. And even into more context, in 2022, Microsoft blocked 1,287 password attacks every second. And that means that in the time it took you to read this, Microsoft has seen more than 10,000 attacks on password-based user authentication. And perhaps the grandest of all ills wrong with password is that they can be phished. And the case study I like to use to explain this is the Beekeeper movie. Who has seen it here? It's quite newish, came out last year, if I'm not wrong. Has anybody seen the movie here? You have, nice. If you haven't, you should actually. It's nice, and I think it's showing in cinemas, or it was showing in cinemas. But in this movie, there was a widow, and she's browsing through the internet and then gets this persistent pop-up that, her device has been infected with a virus, and she's prompted to call a certain number on the pop-up. Now, when she calls this number, unknowing to her, it's a organized attack by an organized scam company. And then she calls the number, and the voice on the other end tells her that, oh, we're going to help you fix this, and just to compensate you for the inconvenience, we're going to send you $500. And so she's expecting $500 when everything is fixed, but then she gets an alert of $50,000. And then the number calls her and is like, sorry. And it's like, oh, I'm really sorry about this. You have to credit back the money, the balance, the difference of the $50,000, because if you don't, then I'm going to lose my job. And she gives in and she logs into her bank account to send back the money. And in doing that, her account is wiped. And unfortunately for her, she was in charge of charity donations. That account is wiped. And then she ended up committing suicide. Now, let's take a look at actually what went down in that scenario. And it probably was that she had visited a compromised website that had some malicious ads on it, and somehow clicked on something. And then when she calls the number and the man on the other end asks her to download something to help them fix her, remove or wipe the virus on her device, what she ended up downloading, unknown to her, was a keylogger. And as soon as she logs into her bank account, the keylogger steals her password for the account and transmits it to the voice on the other end, who now uses it to log into her account and clear her account. And the funny thing is that with how hacking attempts have evolved, even OTPs are not safe from phishing. And the fundamental reason is that if you're using an OTP for authentication, the user has to enter it into a device, and then from that device, he has to be transmitted to the server for verification. And in that movement, it can be intercepted and phished. And with all these problems, the question remains, what if we don't have to deal with all of this? What if there was an authentication method where, one, you're not putting the burden of security and coming up with complex credentials on the user, and the possibility of that credential being stolen is eliminated. And that's how passkeys or why passkeys were introduced. Okay. So, one moment. One moment, please. So what are passkeys? Passkeys are based on a web API known as Web Authentication API, and it has been around for way longer than passkeys, but it's used to implement key-based authentication, that's cryptographic key-based authentication on the web. And the workings of passkeys are based on public key cryptography, where there are two keys, a public key and a private key. Now, the entity or the device or the client hoping to be verified creates a public key and a private key. The private key is stored securely on the device in such a way that it cannot be extracted from the device. It's stored in secure enclaves on the device in such a way that it cannot be extracted. But the public key, as the name suggests, is very public and can be shared with anyone who needs to verify identity. And public key cryptography just solves the problem of how do I securely verify my identity to a party without sharing sensitive information with the said party. Remember that the key problem of passwords and like using OTPs is that that sensitive credential has to be sent from point A to point B, from client to server, and in doing that, it creates an opportunity for hijack and abuse. But with public key, what happens here is that if a server wants to verify the identity of a client, it will send a challenge, which is like a random number, to the client, and then the client will receive the challenge and pass that random number through a hashing algorithm to create a hash digest, and then it encrypts that hash digest with its private key stored on the device. And one important thing to note here is that data encrypted with the private key can only be decrypted with the public key. Now, these keys are mathematically linked, but they cannot be derived from one another. So when it does that, it sends that signed challenge back to the server. And what the server does is that it takes that signed challenge. Remember that the public key can be shared with just about anyone. So the client has shared the public key with the server. And now the server gets back that challenge and decrypts that challenge to produce a hash digest. And then it runs that hash digest through the same hashing algorithm that the client must have run it through. And when that is done, it checks if the result of what's gotten from the hash digest is the same as the challenge is sent. And if it's the same, it's able to verify that, yes, this challenge was signed by a party that is in possession of the corresponding private key to this public key that has been shared with me. And that underpins exactly how, or the fundamentals of how passkeys work, which is why they're quite secure, not quite secure, like very secure compared to passwords. Now, in passkey authentication, there are three major parties or like components involved. You have the relying party, which is the web server that requests are made to. You have the client or the device, and then you have the authenticator. Now, the authenticator can be a bit confusing, but it's, and sometimes people would ask, is it not the device? Yes and no, because there are two types of authenticators. There's the platform authenticator and there are external authenticator. Platform authenticators reside within client devices. So you would have things like the secure enclave on Mac OS devices. You would have TPM on Windows devices or like Linux devices, and TTE in like Android devices. So these chips are designed to generate cryptographic keys and store them in such a way that they cannot be extracted through any means. And then there are external keys, which are, if you work for an enterprise organization here, you probably use a YubiKey. So I also have to point out that in implementing passkeys, you have to be aware that there are two categories of passkeys. There's the device-bound, which is more ideal for enterprise implementations, but we're not here to talk about that. And in that, the passkey is bound to a specific device, which means that authentication must happen on that device. But for consumer applications, we know that I can decide to log into, say, Twitter from my phone or from my laptop. So synced passkeys now emerged, which are more ideal for consumer-based applications. And they allow for seamless authentication for users across devices. And with synced passkeys, the private key is still stored on the device and doesn't necessarily leave the device. But what is synced is like encrypted versions of the private key or encrypted data that through which the private key can be extracted from is taken from the devices and then stored on, say, Apple's iCloud keychain or Google Password Manager. So let's, before I get into technical implementation and code samples, let me show what it actually looks like authenticating with a passkey. Usually I would do this, but at the last conference I spoke at, there was no internet in the hall, so I just decided to record the process to avoid that situation. So this is what authenticating with passkey looks like, and I will explain what's happening. This is the process of creating a passkey for a user account. Okay, I think it has run that. So let me just explain what happened. Now, when you visit a website that supports passkey authentication, ideally you would signal that by clicking a button that you would like to register a passkey for that particular service, and then the server for that service will generate like I explained, a cryptographic challenge and send it to your device, and then the device will now prompt the user for verification. And it does that to ensure you can prompt this verification through biometrics, fingerprint, or like Windows Hello using your voice, or like a PIN. And it does that to verify that this request is being made by the owner of the device. And then after that, the device sends the public key along with, the device creates a public key and then sends that public key to the server along with like device information and other security factors that indicate that it has securely created this set of this public key and stored the corresponding private key securely in a secure element within the device. And then the server now goes ahead to store the public key and associates it with the user ID and also the origin ID. And this is very important because say I'm visiting example.com and I create a passkey on example.com. That passkey I create is associated with example.com, meaning that that passkey cannot be used anywhere else that is not example.com. It cannot be used on another origin. Yeah. And after all that, a user is registered, and then the next time they come back, it will now be for them to log in. So let me just quickly show what it looks like logging in a passkey-enabled service. So here I'm just clicking sign in with a passkey, and it shows me options, and then I just verify my identity with my biometrics, my fingerprints here. And that's it. Now, for what went down there, first of all, I opt in to logging in using the passkey method. And when I do, the server generates, again, a cryptographic challenge for my device to sign. Now, before my device can sign that cryptographic challenge with the private key stored on it, it will prompt me to verify my identity using either biometric or a PIN. And this is usually whatever PIN or method you use to lock your device. So if your device is locked with a biometrics, you verify with biometric. If it's locked with a PIN, you verify with PIN. And in this sense, passkeys are like MFA because there's something that you know and something that you are, which is like your biometric. And in the sense of your device, something that you have too. So it does that, and the server looks up the public key stored during registration, and then it uses this key to verify that the sign challenge that the device is sending back came from the correct private key. And if the signature is valid, the server then confirms that the user identity and grants access to the account. Now, considering this process, let's just take an overview of how passkeys solve the major problems presented by passwords. And if we go back to the scenario I narrated, where the widow received a fake pop-up and she called she thought she was calling an antivirus company, which in turn turned out to be an organized crime hacking syndicate, and then got some sort of keylogger installed on her device. Here's what would have happened if she was using passkey authentication. And now, in the case of passkeys, there is no typing in of like sensitive credentials into any form. And so there is absolutely nothing for the keylogger to log and send to some other server. And so that line of attack is completely eliminated with passkeys. And if we also look at case of like a phishing email where a user was tricked into clicking a seemingly legitimate URL that isn't exactly legitimate but looks like the legitimate things. Say you have Amazon.com and then there's like Amazon, but like the A is like a special character, just hidden in such a way that it's not noticeable. What happens with passkeys is that the user will not even be able to use their passkeys for the legitimate account to authenticate into the fake and seemingly legitimate account because passkeys are tied to an origin, a specific URL. And if it's not that URL, they cannot be used. So that eliminates the attack vector of phishing and credential stealing. And also, passkeys provide better US for users because now the major problem for users being responsible for their own security is gone in the sense that they don't have to remember any complex combinations or whatever. And it also makes lives easier for developers because now you don't have to have all those sorting and hashing, password tables and all of that. You can store public keys as plainly as they are because they are supposed to be public and cannot be used to, achieve anything reasonable. And this is a quote from my friend who is a lead engineer and just implemented passkeys for their product. And this is the feedback he got from most of the users, that it actually creates for a better experience because now they don't have to leave the app during an auth flow. This is a screenshot that I like. So let's just quickly run through technical implementations for passkeys. Like I mentioned, passkeys are built on top of the web authentication API, which have been around for longer than passkeys have. And the web authentication API offers a way for a JavaScript API to enable key-based authentication on web applications. Not all of it goes into passkeys, but a section of it is used to implement passkeys on client applications. So, yikes, I'm actually running out of time. Okay. So in implementing passkeys on the client side, I wouldn't talk about the server side, but on the client side, there are three major steps involved. And the first is to check if passkeys are supported by the user. As of now, say, passkeys have major support across major browsers, but it's possible that some users might be using devices or browsers that do not support passkeys. So you would first check for support before showing the option to sign up with passkeys. If their device does not, or their browser does not support passkey implementations, then it's okay to have them go on with the password auth flow. And so this code checks if the browser supports the webAuthn navigator.credentials, and if supported, it displays the register with passkey button. And yeah. And then the next thing is creating and storing passkeys for the user. Now, ideally, when they click on that button, you would have a form collecting their email or a username before triggering this. And this code checks, again, if the browser supports the webAuthn API. And then, And wow. I'm not sure why this is not showing. Okay, that's weird. Yikes. get some help or just, yeah, okay. Um, Sorry, for some reason, that image is refusing to show up. But yeah, if you want the code samples, I'll just share my slides later. I'm not sure why the code sample is not showing up because it's like in a screenshot. But the code samples I was about to show was just how to implement passkeys on the client side. And if you want to dive deeper on how to handle the data collected from the client side on the server side, there is this repository which contains server-side implementations and libraries that will make the entire process easier. And there's also this guides, which was very helpful for us when we were implementing passkeys for our product. And so for the question I asked, or the title of the talk, if a world without passkeys, are we there yet? And the answer is not yet, but we surely can. And that's because why passkeys are a bit of like a learning curve. It's not rocket science. If like you write JavaScript, you can build out a demo passkey application. And it's very usable, and your users will thank you for it, because apart from like the security gains, the user experience from not having to remember a password is very compounding. And you'll be in good company too, because major companies have added passkey authentication to their apps. And as of today, 93.82% of devices are passkey ready. And passkeys have increased, passkey adoptions have increased with 5 active users having at least 1 passkey. And so there are so many what ifs for, passkeys, around passkeys. But the thing is that there is no such thing as perfect security, and there are things we can do to be more secure, and passkeys is one of those. So, the end. Thank you.